Hello and welcome back. Today we continue our discussion on factoring by talking about how to factor by removing a common factor and then grouping. So let's get started. The first thing you're going to do when you see these types of problems is separate the first two terms from the last two terms, like so. Now that you've done that, I want you to think of what could possibly be the greatest common factor of the first two terms. Well, 4 times 5 is 20, and 4 times 3 is 12, and they both have at least one b, so the greatest common factor here is going to be 4b. So you simply take that 4b and distribute it into the remaining terms. We're going to end up with a 5a right here, and we're going to end up with a minus 3b, and it's minus because the 12 had a minus sign in front of it. There. That's clear. Okay, and then we're going to take the second two terms and see if we can find the greatest common factor. And we see that 3 times 5 is 15, and 3 times 3 is 9. And so we're going to, and they both have at least one c, so we're going to go with 3c on this one. We're going to put our parentheses here and write some information on the inside showing how that 3 can be distributed. So, for the first one, we have a 5a because 3c times 5a gives us our 15ac, and then we're going to put our minus sign here because that was a minus 9b, and we're going to put a 3b here because 3c multiplied by 3b gives us the 9bc. Okay, so now we've done that. And the next thing that you're going to do is to look at this and say, is there any common binomial factor? Well, yes there is, right here. Common binomial factor. Okay, so you take that common binomial factor and you write it out separately. And that common binomial factor is 5a minus 3b. And you can just remove it. So is there anything left? Yes, there's a 4b and a 3c left. So you're going to multiply that common binomial factor against the remaining terms, and you're done. Okay, we have 63xy plus 21x plus 45y plus 15. Okay, so we're going to look at this in terms of first two terms and last two terms. So, are there any common factors in the first two terms? Okay, we'll take out a 21x and we'll multiply that by 3y plus 1 in order to get our original two terms. So let's look at the last two terms. What can we take out of that? We can take a 15 because 15 goes into 45. So we'll take the 15 out, and then we will multiply that by 3y plus 1. These are our common factors, 3y plus 1. So what we can do now is take that out from the whole thing, put it in parentheses, and multiply the remaining terms times that binomial. The remaining terms are 21x and a plus 15. And there you have it. There is there are other types of problems that you will see where you will need to do grouping. And one of them is really complicated. Um, it, Let me just go ahead and cover this just in case you see it. X squared minus 6x plus 9 minus 4y squared. Okay, so we've been putting these into, we've been pairing these up, first two, last two, right? Okay, well you'll notice you can take an x out of this. You will notice that there isn't anything that you can take out of this one here. 3 times 3 is 9, 2 times 2 is 4. What you can do, this is a difference of two squares. So this would be like a 3 minus a 2y times a 3 plus a 2y. But even still, because you would have an x over here, and then you would have x minus 6. Okay, there isn't anything common. You don't have the same binomial twice, like a greatest, a common binomial factor, or common binomial factor. You don't have it. So that doesn't work with this. And depending on your textbook, who your teacher is, you might see these. Okay, so this is what we're going to do to solve it. You can look at this again, and you can also see something else. You can see that the first three terms look like a trinomial, or they look like a perfect square trinomial. Okay, so let's factor that out and see what we get. We put our x's here. 3 times 3 is 9. You know what? It's going to have to be negative, because negative 3 times negative 3 is 9. But also negative 3 and negative 3 added, it would be negative 6, our middle term. So we're going to make these both negative. Okay, and what do we have left over? It looks like we might have a common binomial factors, but what do we have left over? We have from up here the minus 4y squared. So you're probably thinking, wow, this looks a lot different than the other ones do. What are we going to do with that? Well, basically, what you have here, you still have the difference of two squares. Because look at this. X minus 3 times x minus 3 is the same thing as this. It's the same thing as x minus 3 squared. And then you have your subtraction sign, or your minus sign, which is the difference. And then you have another square. You have 4y squared. How about that? As time goes by, it'll become easier and easier to see things. And we wouldn't have been able to see it until we broke it down. We tried several different ways to try to break this down and get something common out of it. And we got something common. We got the x minus 3's. So what is the difference of two squares? Well, when you have a difference of two squares, you write in the set of one parentheses, you do the subtraction, and in the other set of parentheses, you do the addition, and you multiply it times itself. So, for example, it would be x minus 3, and then here's the difference, minus, what's the root of 4? 2. The root of y squared is y. And we need the roots because we're going to multiply this times the other x minus 3. Okay, since it was the difference of two squares, one has to have the subtraction. One of them has to have the subtraction. And the other one has to have addition. Okay. And that's the answer. But here's the deal. I did it on this side. I used parentheses to express that. But the deal is, you don't have to use parentheses because you have an operator here. You have a subtraction sign and then another one an addition sign. So there's no confusion about what's going on. So the final answer can simply be x minus 3 minus 2y times x minus 3 plus the 2y. And that will work. So sometimes they're not cut and dry. You have to try several things, and then you get your common binomial factor like we did up here. But then the problem still kind of looks funny, and you have to do something a little bit unconventional. So this one would have 3 terms in it. It doesn't break down into our usual standard clean form, but that's the answer, and it works. And if you want to multiply all of this, you can multiply them and test it out for yourself to see if it equals the original term. Okay. This one is also going to come out in a way that looks uneven. Well, first of all, if you're lucky, you'll get a situation where you realize that these are all common. It's just that they're rearranged differently. So you'll be like, oh, okay. And you rewrite it as 3. Let's just pick a plus 7 since most of them are arranged that way. 3 times a plus 7 plus c times, rearrange it, a plus 7 minus f times a plus 7. And notice how I wrote the whole thing out. I like to do that. Okay, so you can see that these are all common. You keep your head clear, and you can think clearly when you write everything out. Okay, so we're going to remove a plus 7. And then we just ask ourselves, what's left over? Well, we have a 3, we have a c, and we have an f. So we multiply that 8 times 7 by 3 plus c minus f, and that's it. So if you see something like that, a lot of times the common binomial factor is already there. It's just written in a way to where you might not realize that it's there because some of the terms are flipped around. Okay, so what we're going to do next is probably equations. Equations and inequalities. We've covered all of the factoring. And it's time for us to move on to something else. So stay tuned for the next video. And thank you for watching.